All right, hi everybody. Welcome um, to this channel. Welcome to this session. Today we're gonna be introducing the Learnable Math Science Edition. It's our very first session on physical sciences, and it's quite an interesting and exciting journey for us as well. To just try to explore the scientific sessions. Okay, we're gonna start today with the vertical projectile motion, and I have for you here quite a very interesting question. And I was solving it. I was like, oh wow, this is exciting, and let's see how it goes. So if you're new to this channel, guys, please ensure that you have subscribed, like the video, and just share with friends and all. Okay, so the question says a ball is dropped from rest, right? From the top of a building, which is like 15.2 meter high, right? So, very quite interesting thing happens here. They're saying after this ball A, as you can see in the diagram here, after ball A has dropped to a height of 3.2 meter, a second ball, which is on the ground, which is B, is then projected vertically upwards, right, from the ground. So after a while, the two balls strike the ground at the same time. I know quite a number of you might be saying, oh, how is that possible, right? I think there's quite an interesting thing to explore there. Okay, so they're saying ignore the effects of air resistance, right? And the first question, they just want you to define the term free fall, right? Okay, what is free fall, guys? We do know that if we ignore the effect of air resistance, air friction, all those other things, free fall would describe the motion of an object that is only under the influence of what? Gravitational force. So the only force acting on that object would be the gravitational force. Then we say that object in motion experiencing only gravitational force, it's in a what? It's in a free fall. Okay, so that is it. 3.2. Calculate the time taken for ball A to strike the ground. Remember, you are dropping ball A from a height of 15.2 meters, right? We want to know how long will it take for this ball A to strike the ground. So the first question, the 3.2.1, it's fairly easy, right? So remember, when answering vertical projectile motion question, we have to choose the direction. This is very important, guys. Because it has an impact on the signs of your variables. Okay, so I'm going to let downward be what? Be positive. So I'm choosing downwards as positive. Okay, so what do I have for my data? Is that if I'm dropping this ball here, its initial velocity will be what? 0 meter per second. Okay, and again, it's been dropped from a height of what? 15.2 meter. It means my change in y will be positive 15.2 meter because it's going downward, right? It's covering that distance, so it's positive because I let down to be positive. Gravitational acceleration will also be positive 9.8 meter per second because the ball is going downward and my direction, I'm saying down, be positive, so it's going in the direction of motion, okay, of gravitational acceleration. Then what we need is the what? Is the time. What is the change in time? Okay, so from your vertical projectile motion formulas, we can see that we can go and incorporate this formula. Change in y is equals to v initial, change in time, plus half a change in time squared. All right. So because we have change in y, we have v initial, we are looking for change in time. Okay. So my change in y is 15.2. My initial velocity is 0 times change in time plus a half. My gravitational acceleration is 9.8, right? Change in time, what? Squared. Okay, so the rest is just doing the maths. Then we can find the time it takes for ball A to reach the ground. So it's 15.2. This will be 0 plus 1 over 2 times 9.8 is 4.9. Change in time squared, right? So this will be 15.2 divided by 4.9 is equals to what? Is equals to change in time squared, because 0 it's just gonna go, then we divide both sides by 4.9, then change in time is equals to the root of 15.2 divided by 4.9. Then we can calculate the time it takes for this ball to reach the ground. Okay, so it will be the root of 15.2. This must be 15.2 divided by what? 4.9. Then we see it's going to take 1.76 seconds for ball A to reach the ground. Okay, so we have answered question 3.2.1. Very, very interesting question that I want us to focus on is 3.2.2. Quite a tricky and exciting question. Okay. Calculate the magnitude. Let me zoom this. Calculate the magnitude of the velocity with which ball B was projected from the ground. Okay. Guys, this is quite interesting because there's something that's happening here. We are told from the statement that after ball A has fallen about 3.2 meters, so it was somewhere here, ball A, right? This is our ball A at this height, right after it has fallen 3.2 meters. Ball B is then projected vertically upward, right? But what is quite interesting is that these two balls strike the ground at the what? At the same time. I think that is quite very helpful for answering this question, right? Because if these balls have to strike the ground at the same time, um, uh, uh, that means that the time A took to move from this position, which is 3.2 meter below the 15.2, from that position going down will be the same as the total time ball B would have taken to move to go to the maximum height and to also come back to the ground, right? It means that, and that only makes sense to say, okay, it means that if ball B has to strike the ground at the same time with ball A, right? It means that when ball A was at 3.2, when they were starting to project ball B, it must go up and fall down, because it goes up and fall down, reach a maximum height, falls down at the same time that ball A takes to move from that position going downward. Okay, so now it changes the height now here, right? Because the new height for this will be 15.2 minus 3.2, because the projection of ball B only happens when ball A has moved down to 3.2 meters. Okay, so we have our new change in Y for this event when ball B is being projected, right? Which is like the total 15.2 minus 3.2. We just want to know at what position was ball A, right? So ball A was 12 meters from the ground. Okay, so it's like 12 meters from the ground there. Okay, so what happens when ball A was 12 meters from the ground? Ball B is then projected up, right? But quite interesting, as I said, they strike the ground at the same time. It means that the time it takes, change in time for ball A, is the same as the change in time for ball B's motion, entire motion going up and down, so that they hit the ground at the same time. Okay, but guys, remember that we are looking for the initial. What was the initial velocity that ball B was projected with to ensure that it strike the ground at the same time, right? So what we can do rather in this case is that we can first go and calculate the time it takes for ball A to move from 12 meters above the ground to strike the ground, right? So that we know that what is the total time that it takes for ball B also to go up and down, right? Because they are the same. So we can go and calculate time for A. And I'm just going to first start by letting down to be positive, guys. This is very important. Vertical, projectile, don't forget, you have to always choose your direction. Let down be positive. Then I want to calculate the time it takes for ball A to move from that 12 meter going downwards, right? So obviously the initial velocity for ball A there is 0 meter per second, and the change in Y now changes to be 12 meters, right? Because it had fallen like 3.2 meters down. Okay, so it's 12 meters. The gravitational acceleration is still 9.8 meter per second squared. Then we can go on our formula, right? Which is change in Y is equals to V initial change in time plus half A change in time squared and Gwen solve for time, right? We do not change in Y is 12, V initial is 0, change in time, plus half 9.8, change in time squared. Okay, so we have something like 12 is equals to 4,9, change in time squared. Then the root of 12 over 4,9 will be equals to what? Change in time. Then we can find the time it took for that ball to move from that position to the ground. Say 12 divided by 4,9. Then we have the time, and you can see it is quite reduced from the total time when it was at 15,2. Can you see? Takes only 1,56 seconds to move from that position going downward, right? Okay, remember what we said. For them to strike the ground at the same time, it means the total time for that it takes for ball A to move from that 12 meters going downward um, will be the same as the total time it takes for the whole entire motion for ball B, because they have to strike at the same time. And also it emphasized on the statement that they strike the ground at the same time. It means that this is only possible when the time from A to the ground is the same as the entire time for ball B moving upward, going downwards. Okay, now after calculating this time, remember we want the initial velocity of ball B, right? So what we're gonna do here, guys, we are just only gonna consider the half motion of ball B, right? What do I mean by half motion? From the ground to the maximum height. We do know that V final for ball B at the maximum will be 0 meter per second. Okay, so if we are considering only the half motion for us to get the V initial, right? So it means that that total time we calculated for A to move from that position to the ground, which is the total time for the entire motion of B, will now be divided by what? By 2 to get the half motion of B. Okay, so what we're gonna do is, if we're considering half motion, we are looking for the V initial, right? So we don't have V initial yet. We know that V final is 0 meter per second. Okay, so change in time, it won't be 1,56, guys. We do know that 1,56 is the total time that B must have traveled the entire motion, right? But which is the same as the time A takes. But if we're considering half motion, because remember with B, it's not one motion, it's sort of like double motion. There's motion from the ground to the maximum height, from the maximum height to the ground, right? But the entire motion takes what? 1,56, as we calculated as being the same as the one for A. But if we're considering half motion, we'll have to divide this time by what? By 2. Okay, so it will be 1,56 divided by 2. Then the time will be 0, what? 78 seconds. Okay, then now we can go and use the formula V final is equals to V initial plus a change in time to now finally get the initial velocity. Remember, we are using the direction saying let down be what? Be positive, right? Okay, so V final is 0 because at the maximum height, the final velocity is 0. Then we're looking for V initial. What is our acceleration? So in this case, we are saying let down be positive, but the ball is going up, right? So the acceleration will be what? Negative 9.8 because it's going in the opposite direction there. Change in time, we calculated is 0,78 seconds. Okay, so we can put this on the calculator and we see what we get as the initial velocity minus 9.8 times 0,78. So the answer will be minus 7,64. All right, so the initial velocity is 7,64 meter per second. So this is the magnitude of the initial velocity with which ball B must be projected for it to strike the ground at the same time with ball A. Okay, this was quite an interesting question, guys. The trick really was just you thinking remembering, going back to the statement and checking there to confirm that, okay, for this to happen, for ball A and ball B to strike the ground at the same time, obviously they must have traveled with the same time, right? It means that the time, we had to first calculate the time it takes to move from that position going downwards. We got 1,56. And then when we move for ball B, it was quite different because ball B had to go up and down. And we then considered the half motion, right? Hence, we had to divide that total time by what? By 2, so that we consider the half motion. And we use that to find the initial velocity. Okay, I hope you find this session very helpful. Guys, don't forget to like, share the video, subscribe if you haven't subscribed, and let's meet on our next session. See you soon. Bye.